I'll get started. Thank you for coming. I'm Patric Curran. I'm chair of the Java Community Process Organization. I'm going to talk to you about careers and getting involved and how we develop Java and how you can help. First of all, a little bit about me. I'm originally, my family's from Ireland, but I was born in England. I live in the US, and I'm married to a lady from Turkey. So I'm kind of mixed up. I like to travel, and I'm very glad to be here in Austria. It's my first visit. Hope it won't be my last. Glad to be in Vienna, a city famous for its music. I'm a big fan of music. I love music. I'm going to be talking a little bit about that as we go through this. My last trip was to another musical city, Rio de Janeiro. I was there last month, or January. Last month. It was just before Carnival, so I was lucky enough I didn't get to see the full thing, but I did get to see some of the samba schools practicing. This was Copacabana Beach. I love Brazilian music, so there's a club I go to in Sao Paulo, a small place where they play samba. And the music there strikes me as it's people's music. Everybody knows the songs, they know the tunes, they dance to them, they can sing along. And it reminded me, like I said, I'm of Irish background. See the similarity with Irish pubs where you will have people playing, everybody in the audience will know the words, will join in and will sing. So music is a kind of universal language. Last year I was in Congo, in Africa, and I speak a little bit of French, but not a great deal. But I was able to get on with people because I love Congolese music and we could share our love of music. So music is like a universal language. People all over the world can kind of share feelings and expression. Technology is similar. I'm going to encourage you to share your passions and your enthusiasm with your fellow developers all over the world. You can make friends, you can advance your career, and you can have fun. And that's what I'm going to be talking about. I've been in the business for more than 30 years. I had no intention of becoming a computer person. I was an academic. I was working on a PhD in economic history. And I buried myself in libraries, and this was in the days long before terminals and stuff. So all you had was those card catalogs. You probably don't even remember them, but little boxes with little cards with the names of stuff written on them. And because the stuff I was researching was 19th century, there were no big compilations of references. Everything had to be kind of tracked by hand. And at the time I thought, there's going to be an easier way of doing this. There will be an easier way of doing this in the future. People will sit at some kind of magic box and they will kind of ask questions and answers will come back. And in the end I got more interested in how I might sort of help to make that come about than in the subject I was supposed to be studying. So I went to what we call a night school, technical school, learned to program, taught my way into a junior programming job. I'm going somewhere with all of this. This is my first computer. At least I think it looked like that. I don't know for sure because I never saw it, because of course you didn't get to go to the machine. You got to type in something on one of these terminal thingies like this, and you put your program on punch cards and you had a big stack of them and you take them somewhere and you'd hand them to someone in a little booth, and then you'd wait 24 hours and then they'd come back the next day and say, oh, you got a syntax error in line 3 or whatever, and you'd have to go through the whole process again. So you became very good at debugging stuff in your mind rather than relying on the computer to do it for you. I did talk my way into a job, and the first day on the job I was given a choice. The boss said there was 2 rooms, there's one over here and one over here. He said, you can go work over there with those guys. And I looked in there, there's a bunch of guys not in suits, but in shirts and ties and smart clothes and stuff. And they were coding on COBOL coding pads. And I thought, that looks a bit dull. And then he said, oh, you can go over there. And in the other room, there are a bunch of scruffy looking guys, and there were all these kind of single board computers and circuit boards and wires and stuff trailing all over the place. And I thought, that looks more interesting, I'll go work with those guys. And we worked on the very first microprocessor-based systems. They gave me a computer, this was it. 8 kilobytes of memory. The only storage was this little cassette thingy over here. And I learned to program in assembly language because that's the only way you could actually fit anything into 8 kilobytes. And 6502 assembly language may look sort of familiar to you, to those of you who are familiar with Java bytecode, because of course bytecode is just an assembly language, if you like, for a virtual machine as opposed to a physical machine. So, because I called myself an assembly language programmer, one weekend, one Friday, the boss came to me and said, "Do you want to go to California for a year?" I said, "Well, I don't know, but yes, okay, I'll go." And they put me to work programming the software for a word processor, which in those days didn't mean a program, but a physical device. This was it. It had a printer attached, and took 5¼ inch floppies. It ran CPM, but it was basically a special purpose computer that did only word processing. And the company went bust after a couple of years, and I got recruited into another company called Interactive Systems, and I led a team that was developing an emulation of Unix that ran on VMS. You might wonder why anybody would do that. But our customers were primarily government agencies and other people who had an obligation to preserve text over time, documents, and to be able to reproduce documents 20 years from now such that they looked exactly the same, were formatted the same way that they are when they were originally produced. And the TROF formatting language that came with Unix was one of the very few ways that you could do this. So that was why we were selling that stuff and why they were buying it. But then I moved on to work with a team that was porting Unix to a whole bunch of different hardware systems. In those days, there were all these mini computer companies, Prime, Data General, Wang, and so on. And we also did Unix for mainframe systems for Hitachi and IBM. But the most interesting thing we did was to put Unix on the original IBM PC XT system. 64 kilobytes of memory, 10 meg disk. We put a full Unix on it. IBM had no idea how to sell it, so I don't think they sold very many. But I still have as a souvenir a box of 19 5¼ inch floppies, which is an actual copy of the system. Of course, you'd be hard put to find a machine on which you could load those things today. So there's a lesson there. This is only 20-some years ago, and already, there's stuff that is lost. So we need to think long and hard about the formats that we use to store data and how we might be able to retrieve it, not just 10 or 20 years from now, but 50 or 100 or 500. There's a reason people wrote things down in books. Books last. Encoding schemes don't. So something to think about. As an aside, but to go back to music, in the early days, at least where I was, there were very few people who had come through computer science courses, and so I had to figure out some other way of figuring out whether somebody would make a good programmer. And eventually I realized that if they were a musician, they played an instrument or whatever, then there was a good chance that they would become a good programmer. I'm not sure exactly why that was. Something to do, I think, with the fact that both are creative acts. You have this notion of elegance in both. You talk about a mathematical proof. You can have a proof that is correct but ugly. Similarly, same as you can have code that works but is ugly. And then you can have a proof that is concise and elegant and even beautiful. And I think that aesthetic sense is coupled with the creativity is what made this connection between music and programming. So where am I? That was my 4th job. Notice I haven't actually done an interview except for the very first one. That's the only interview I've ever done in my life. Scott McNeely bought the company that I work for. He was getting a little afraid that PCs were getting faster and cheaper and might eventually pose a threat to Unix, to Sun workstations. So he thought, we better have a backup. So let's put Solaris, which is their version of Unix, onto Intel boxes. We were the experts at doing that, so he bought the company. So I worked on that for a couple of years, several years. I managed a bunch of kernel and device driver developer types. We started outsourcing back then, originally to Ireland. You might think that's a bit odd, but in those days, Irish were not paid that much. They were well situated for the European market. They were English speaking, and so people in the US thought that would be a good idea. I'm mentioning this, I'll come back to it later, but no matter how good you are, somebody out there is going to do your job cheaper than you can do it. So you've got to watch out for yourself in your career. We stopped outsourcing to Ireland, then we moved on to Russia. After that, we went to China. Who knows where it's going to be next. Eventually, Sun said, oh, we changed our mind. We don't want Solaris on Intel anymore. Dumped it, laid us all off. I managed to get another job in the Java organization. Talking about outsourcing, most of my team were in Russia. In one team in Siberia, another in St. Petersburg. My wife said I was probably the only person she knows who would say, when told, you're going to have to go to Siberia, said, yay, that's good. I like to travel. Yeah, Siberia's Novosibirsk, that's where we were. So that's a pretty long way from California. And then I moved on to become chair of the JCP. I was just told, you've got to do this. And then it was now. So why am I telling all this long story? You're going to plan your career, you've got to plan for change. That's about the only thing you can plan for. When I started, there were no laptops or networking or email, no internet, no bitmap displays or GUIs, no cell phones, nothing. And if you were trying to look forward 5 or 10 years, you really had no idea what the future was going to bring. I think that applies today also. You may have some idea of trends for the next few years, but if you think over the lifetime of your career, what things are going to be happening 10, 20, 30 years from now, you've no idea. So all you can predict really is that things are going to change, and that they're going to probably change in ways that you did not expect. So here's an example of change. When I started, this was a Cray supercomputer, cost about 10 million bucks. This is more powerful. We're all carrying around supercomputers in our pockets. Now, we didn't predict that back then, except possibly in science fiction. But most science fiction predictions did not come true. We don't have our flying cars. So you don't know what's going to happen. So you've got to learn to switch metaphors away from music. I think of it as like surfing. I've had about 7 jobs, and they sort of flowed one to the other. I didn't consciously choose any of them except the first one. And then it was a matter of seizing opportunities as they came up. So all you can do as you plan your career is get yourself in a position where opportunities are going to occur. That's the important thing. So, if you get a choice between 2 jobs, think about which of them is going to give you the most opportunity to learn, to make new contacts and so on. But the best you can do really is put yourself in that position and then seize the opportunities that come up. Find a good wave, choose an interesting one, hop on and ride it and see where it goes. It may not go where you expected, but you'll probably have fun along the way. So one way to create those opportunities, one way to make sure that more opportunities present themselves to you is through collaborating with other people, connecting, teamwork. So connect with people, collaborate with them, create stuff together with them, and you can think of that as being also like making music. The more of this you do, the more opportunities will present themselves, the more you'll learn, and the better you will get on in your career. So that's the kind of preamble. Let me check my time, see how I'm doing here. Okay. So let's move on now to talk about Java and standards. First of all, standards. Standards make the world go round. The world that we live in would not function if it wasn't for standards. Standards enable everything in modern life, from medicine to technology to social relations and so on. And there are hundreds, literally hundreds of standard-setting organizations, one of which is the JCP, and I will talk about that in a moment. But the essence of standards is, there's basically a standard is just an agreed upon way of doing stuff. But the big advantage of standards is once you have a technical standard, then you can have multiple implementations of that standard. And that means that people are not locked into buying all their stuff from one vendor, as they used to be in the old days. If you bought a computer from IBM, that was it. They owned you for life. You had nowhere else to go but IBM when you wanted to upgrade the computer, when you wanted peripherals for it, when you wanted software for it, when you wanted people trained to use it, and so on and so on. If you were an IBM shop, you were an IBM shop forever. And customers don't like that. They like to have a choice. And standards are what give people choices because they enable multiple implementations. And at least in theory, you can dump one vendor for another, or you can mix and match stuff from different vendors. And people who build industrial strength systems, global supply chains, ATM networks, rockets in space, cell phones, so on and so on, they want choice. They don't want to be locked in, so they want to build stuff on top of standards. Two kind of standards that we care about. First is languages and protocols. Hey, sorry about this. Languages that we use to speak to machines, or that machines use to speak to each other, basically. And the other is interfaces. When I started on that little Commodore machine writing an assembly language, there were no routines, no libraries, no nothing. If you wanted to do something as simple as read an input from the keyboard, the only way to do so was by going and looking at particular locations in memory and decoding what you found there as the keystrokes were dropped into there. Today, of course, you can collect publicly available libraries and routines, and if they're well defined and the interfaces between them are well defined, you can plug them together. So standards for interfaces are also very important and of interest to us. And in Java, our standards come out of a collaborative community process. Stuff doesn't come down from on high like it does in the Windows world, for example. With Windows, what you get is what Microsoft decides you're going to get. If you're a really big customer, they may consult you and ask you for some input. But basically, they decide. It's not the way Java works. Java comes through a collaborative development process. We develop specifications, we call them JSRs, which we develop collaboratively. And everybody who's involved and who cares about or is interested in this particular technology can participate in it. So not just Oracle, but some of Oracle's biggest, most active competitors, IBM, HP, Red Hat, I should say HPE now. Hewlett-Packard Enterprise. They're all big competitors of Oracle, but they collaborate with us and with others to help advance Java. We also have representatives from the open source community, the developer community, and so on. Won't go into the details. This really, what I'm trying to say, what I am trying to say here is that for each of them, can I switch to this? This is awful. Let's see. Hello? Hello, hello? Can you hear me? It's not working, right? Can you hear me? Yeah. Back? Okay, I'm just going to speak loud. If I become too quiet, just raise your hand and I'll speak up again. Sorry about that. So for each of the three platforms, we have a bunch of technologies. The interfaces to these technologies, the ways that you invoke them, the way that they plug into each other, are all well defined. For Java SE, Java ME, and Java EE. And typically each of these pieces, these building blocks, if you like, have their own specification developed through the JSR process. Basically, a JSR is a specification for a single version of a particular technology. They're led by somebody in the JCP, some member of the community that we call the spec lead, specification lead, and they recruit a bunch of people to help them, again, members of the JCP, and collectively they form what we call an expert group. This is very similar to the way that other standard setting organizations work. Sometimes they call them technical committees or working groups or whatever, same principle. Anybody in the organization can propose and can lead a JSR, but it's not for the faint of heart. There's a lot of work involved, which is why typically they're run by organizations rather than by individuals. Though we have had a few, small number of JSRs successfully led by individuals. But you have to deliver three things, not just the spec, but also a complete implementation of the spec, which we call a reference implementation, and also a set of tests we call a technology compatibility kit. Most people would call it supposed to do. So when the JSR is originally being developed, before you complete it, before you can finalize it, you have to deliver all these three things. Thank you. Okay, that's much better. All right. And each of them kind of builds on the other or strengthens the other. So creating the reference implementation verifies whether or not the specification is actually implementable in the real world. When you develop your tests, you will find bugs and ambiguities in the specification, which you will fix. So the process of building tests strengthens the spec. And then as you run the test, you will find bugs in the tests and bugs in the implementation. So all three of them kind of strengthen each other. And compatibility testing, as we call it, which basically means that all implementations of a Java technology must pass the associated test suite to verify that they're complete and correct. And once they have done so, then they get a kind of seal of approval, get to use the trademark and so on. And users then have some reasonable guarantee that when they get an implementation from vendor A, it's going to be compatible with the implementation from vendor B. Will have the same features and they will perform in the same way. Okay, we're structured. I'm the chairperson. There's an executive committee, which is like a board of directors, more on them in a moment. There's a small administrative staff. The real work is done by these represent the expert groups, and the members will participate as members of expert groups and also get to vote on members of the executive committee. More on that in a moment. There are 25 members of the executive committee, and they vary from big vendors that implement Java, such as IBM, of course Oracle, Red Hat, HP, to those who consume Java, such as, for example, Credit Suisse or Goldman Sachs. We have Twitter, who use Java. We have a couple of companies that do kind of machine-to-machine or IoT, Internet of Things type technologies, V2Com and Microdoc. We have a couple of individuals, Werner Kyle, Geir Magnussen, a couple of Java user groups, London Java Community and So Java, and we have Eclipse Foundation representing the open source world. So we try to make this as representative and as inclusive as we can. Geographically, we are mostly American and European, but we do have 3 members actually in Brazil, and from time to time we have in the past had people from the Far East, but we don't at the moment, so no Koreans, no Chinese. I hope we can fix that in the future. As far as the membership is concerned, anybody can join. We got about 900 members today. I hope that's going to go up in the next year or so for reasons that I'll talk about in a little while. There are no fees. About 3/4 of members are individuals. 16% are corporate, but of course for every corporate member there will be many representatives, employees of that organization that will participate. So the absolute numbers of participants not represented by these, but in terms of actual membership numbers, these are the proportions. And we're about 40% in North America, 40%-ish in Europe, Middle East and Africa, 13% in Asia and 6% in South America. So Asia is probably underrepresented. South America probably okay because of the big Brazilian participation. Okay, I won't go into details here, but the important point is we have a formal process for developing JSRs, starting with the initial proposal. There is a vote on this at this stage by the executive committee, yes or no. Is it a good idea? Is it not? They almost always say yes, but once in a while they say no if somebody comes up with a harebrained idea to standardize something that is not ready for standardization. So that's typically the reason they will vote no. Then we go through a period of developing one or more early drafts. When you have it more settled, you do a formal public review, you publish a spec, you request feedback from the public, there's another vote at that stage, and then more drafts, and then there's a final approval ballot at the end, are we done? And then we go into a maintenance role. And all of this is defined in what we call the process document, which is available on jcp.org. Excuse me a second. Okay, switch gears just slightly to talk about how we change the way the organization is structured and organized. I think of that as changing the constitution of the JCP itself. The constitution, which is basically the legal framework and the governance and how we operate, is defined in two documents. One is the process document that I just mentioned. It defines the governance, the structure of the executive committee, the processes that we use for that formal process of moving the specs through the process, and the obligations that the expert group has to produce the deliverables at the end of the process. The other document is a legal agreement that people sign when they join, and that mostly addresses intellectual property matters. You think of these two documents together as the specification for the JCP. And since we know how to revise specifications, because that's what the organization does, we use exactly the same process to modify these documents. So we file a JSR. Typically, I, as the chair, will be the spec lead, and the executive committee members will form the expert group. And then we go through the same process as we do with a regular technical JSR, publish the drafts, there are votes, and so on and so on. And at the end of the day, one or other of those documents, or maybe both of them, are updated. For the past few years, we've been working on a series of JSRs, which we have collectively called JCP.next, meaning how do we define the next version, to make changes to the way we operate. And I'm going to talk about two of them here. The first one was JSR number 348. And people thought that this was how expert groups operated. A bunch of guys, and typically they were guys, would go away, sit in a smoke-filled room, have discussions, and eventually, sometime later, a spec would pop out. It wasn't entirely true, but there was some truth to that. We said, no more of that. We want everything done out in the open. So the expert group must publish all of the minutes of their meetings. They must let people know what they're doing. They must publish the working drafts of their documents. They must have an openly readable, accessible issue tracker, and so on. So a bunch of simple things. It only took us about 6 months to finish this JSR. It was easy to do. Everybody agreed it was really a no-brainer. And as a result of that, we saw a big spike in interest among developers in actually watching what we're doing and participating in what we're doing, because now they could see what was happening and felt that we were genuinely trying to make things accessible to them. And we had a bunch of Java user groups joined after that, and through a program called Adopt-a-JSR, which I'll talk about later, significant increase in participation. We have another JSR which is in its final approval ballot process as I speak. In fact, today is Monday. At midnight tonight, California time, the ballot will finish, and this JSR will, I'm sure, be approved and will then go into effect. And this one had the goal of making it easier for individuals to join the JCP and to participate in work that we do. And the primary thing that it does is create a new class of membership that we call associate membership, which is much simpler. Today, if you want to join as an individual, you have to sign that JSPA thing, which I didn't talk much about, but it's a big, scary legal document. It's 12, 13 pages long, and even lawyers don't fully understand it and agree on what its contents mean. Lawyers will disagree. You have two lawyers and give them this document, and I've done that. And one bunch will say, well, this means this. Another will say, that means that. And a third will say, I've no idea what this means. Can we go back and talk to Jonathan Neimer, who was the lawyer at Sun who drew it up in the first place? Because he's probably the only person who knows what he was intending. So we're replacing that with a much simpler membership agreement that you can read and probably understand by yourself. But more importantly also, you don't have to go and get permission from your employer. With the JSBA you do. You have to actually get your employer to sign an addendum to that document. It's not a big thing, but if you've ever tried to get the attention of your company's legal department, you'll know that they're not typically very happy at being asked to read a 13-page legal document just so you can indulge your weekend hobby of hacking on Java code or whatever. So the associate member agreement will not require an employer signature. The other thing that it will bring is an opportunity for formal recognition as a contributor to a GSR without you having to go through the heavyweight process of becoming a member of an expert group. To become a member of an expert group, you have to be pretty sharp technically, not just sharp, but deep experience, and there's a fairly significant amount of investment of time that you need to make. This may well be more than most people are able to give as individuals. But the change that we're going to make is that there are now many other ways you can participate, which I'll talk about later. And if you have participated in one of these ways, perhaps by developing some test code or by providing some feedback or whatever, and the spec lead agrees, then you can get your name posted on jcp.org on the web page associated with the JSR as a contributor to that JSR. And that, going back to careers and career advancement, is a big deal. Employer is hiring, says, I want people who are familiar with this particular Java technology, whatever it is. Two people go in. One of them says, yeah, I'm familiar with that technology. I've been programming in it for years. Second guy says, yeah, I'm familiar with that. Not only have I been programming in it for years, but I helped to develop the latest version of the spec. Go look at jcp.org, you'll see my name there. Which one would you hire? It's pretty obvious, I think. So I think that's going to be a big deal. We're also introducing a new membership class for Java user groups that are not legal entities. This is a detail, but it's an important one. And we've eliminated, or in the process of eliminating, all fees for corporations. And like I say, midnight tonight, California time, this will go into effect. Okay, so the result of what we've been doing here is to try and make sure that, we call ourselves Java Community Process, but to try and really make sure that the community can participate. So we open things up, we made them transparent. We're going to make it even easier for people to join. We'll start yet another JSR probably in the next few weeks to kind of tie things up and to make some more tweaks to the process. This will primarily be an embrace of open source and collaborative development processes to make sure that everybody is doing stuff really collaboratively. So we're trying to get rid of all the barriers to participation. So, if you care about Java and you're interested, you can't say it's too difficult for me to get involved. You may say I don't have the time or for whatever other reason, but you'll have no real excuse for not getting involved. So that's what I'm encouraging everybody to do. Question, of course, is why? Why would you? Corporations, there are a number of reasons why corporations feel they want to get involved in the standards process. They want to influence standards rather than just have them dropped on them. Perhaps influence them in a direction that will make it easier for them to incorporate them into their products, because they feel that collaborating even with their competitors makes the whole market bigger for everybody. It's just makes good financial sense, and also to give themselves a competitive advantage, because that means they will really be on top of the new technologies if they help to create them. As an individual, and by the way, if you're interested, and when people come to us and say, I want to join as an individual, we always first ask them, well, are you working for a company that is interested in Java? Maybe you can persuade your company to join. But if you do join as an individual, yes, you can do it because it feels good. It's good karma. But that's not the reason that I'm asking people and suggesting that you do it. I'm suggesting that you should do it because it will be good for you. So for purely selfish reasons, you should do this. You'll gain good experience and you will make fame and fortune, or at least more than you would have if you didn't do this. How to participate? Back in the early days when I first started doing this job, we did have a number of people say, I want to join, and I encouraged them to do so as individuals, but then they were kind of stuck. It was just me. What am I going to do? I can't go join that expert group. It's full of big, heavy-duty technical guys from IBM and Oracle or whatever. In those days, things weren't as open and transparent as they are today, and people just said, now I don't know what to do. And eventually we figured out, or rather a couple of Java user groups figured out, which I'll come to a little later, that working through your user group is a much better way to operate. You can help each other, you can teach each other, and you can work together. And collectively then, it's not just one person, but you have a whole group of people, typically in the same city or geographical area, and collectively they can work and help each other and participate much more effectively than if they were doing so as individuals. You have a user group here in Vienna, and if you're not a member, I encourage you to join. We have a whole bunch of user groups that have already joined the JCP. I think we're at about 50 now. Every time I rev this slide, I have to change the font to make it smaller so I can fit them all on. But they're from all over the world. We do have two jugs, as I mentioned earlier, who are on the executive committee, so helping to drive the direction of the JCP itself. One is Sojava, based in Brazil, led by Bruno Souza, who you've probably heard of. He's the guy who wears the Brazilian flag at Java 1. And the other is the London Java community. Again, names you probably recognize. Both of these groups got together and defined and invented this program they called Adopt-a-JSR, which is basically, I'll come back to that. We have user groups from all over the world, as I said, working and helping to implement and to test JSRs. Here are a bunch of examples here. I won't go into the details, but you will see we have a bunch in Europe, a bunch in South America, a bunch in Africa, and North America, of course. And they have done various things to help the development of JSRs. The Adopt-a-JSR program basically just says you get a bunch of people in a Java user group who are interested in a particular technology, and then they just say, okay, we're going to see what we can do to help. I'll say a little more in a moment about the kind of things you can do to help. But first of all, back to why would you do this? To advance your career, for selfish reasons. Why do people come to conferences like this? For the same kind of reasons, I'm sure. You want to improve your technical skills. That's important. But more important than technical skills, because we kind of assume that everybody has good technical skills. If you want to get on, you need to have a bunch of other skills also, because remember what I was talking earlier about outsourcing? First of all, it was Ireland, and it was Russia. Now it's China, or India, of course. So I don't know where they came. It went India, Russia, no, excuse me, Ireland, Russia, India, China, and then who knows where, Romania, Vietnam, whatever. So no matter how technically savvy you are, there's somebody else out there who knows as much as you do technically and is willing to work for less money. That's just a fact of life, okay? The way you get around that, the way you protect yourself, is by recognizing that on top of those technical skills, there are a bunch of other skills that you need. Human resources people typically call these soft skills, social skills sometimes. Verbal and written communications, and that means in this world not only being able to communicate efficiently and effectively, but being able to do so in English, because that's kind of the language that typically is used, as we can see at this conference, but also collaborative skills, knowing how to negotiate with people, knowing how to collaborate with them, work with them, when to push back, when to compromise, and so on. All of these skills are exactly the kind of things that you learn when you participate in some kind of collaborative development process, whether that be an open source project to develop software, or whether it be a formal standards development process through a standards developing organization such as the JCP. Working in those kind of organizations, and I'll focus mainly on the JCP or on standards development, is a wonderful way to to grow your skills and to develop your career. You will build an international reputation because you're going to be working with people, certainly in North America and often in all around the world, and you will learn exactly these skills. Not just, and you will make good, you'll learn technical stuff too. Put all this together, and that's the way to grow your career, to protect yourself against having your work outsourced and so on. How am I doing here? Almost done. And unlike becoming a member of an expert group where you have to be really technically strong, you don't have to be a super expert to be able to help. There's a number of things you can do. You can evangelize, you can help with documentation, you could work on an FAQ or a wiki, you could work on project infrastructure. So all of those are things, you can get started with something relatively simple. And then you can move on to more complicated, more technical things such as issue reproduction, prioritization, thinking about how the particular API that this JSR implements could be used in the real world, perhaps write some small test programs or take a program that you already have and modify it to use these new APIs, provide feedback that way. You can help to develop the test suite. You can do testing of the implementation, and you may be able to actually help with the implementation itself. So there's a whole range of stuff you can do, from pretty simple, like a little bit of tweeting or blogging, a little bit of documentation work, all the way up to kind of heavy-duty technical stuff and everywhere in between. If you're more interested in the implementation rather than the specification, then you can work for Java SE through OpenJDK, which is the open source project for developing the reference implementation for the Java SE platform. And similarly for Java EE, there's Project Glassfish. So both of these are open source projects where you can get your hands on code and learn about the new technologies that are coming in the next versions of the platform, and at the same time help the spec leads and the expert groups to make those implementations better and stronger. So, Java was 20 years old last year. Don't know if it'll last to the 25th century, but it's certainly going to be around for the lifetime of your careers. COBOL's still alive today. And by the way, sometimes people say, Java's getting old and tired, kind of like COBOL. Java is not just the language. The important thing about Java is the JVM. There are more than 100 different languages run on top of the JVM. And anybody in these days who thinks of writing a VM to run some new software platform that they're interested in, if they want to start from scratch, then they're just wasting their time. You know, the JVM has been around for more than 20 years. It's been fine-tuned by some of the most smartest developers on the planet, and it's going to be around for a long time. So going back to what I was saying at the beginning, we don't know what the world's going to look like 20 or 30 years from now, but these kind of technologies and the skills that you will learn in participating in developing them will position you in the best way that you can be positioned to be successful 20 and 30 years from now. So whatever Java is or whatever it evolves into over the next few decades, you can help to guide that. You can define the future of Java, and I encourage you to do so. That's it. I have maybe 3 or 4 minutes if anybody has any questions. Otherwise, I will be around and you can grab me later. Any questions? Feedback? Okay.
What's the typical process when a new standard, before it's being suggested and usually a library and it becomes very popular and then it's being decided that should become a standard?
Good question. That's typically the way that I believe it should happen. We sometimes get people come to the executive committee or contact some of us and say, I've got a new idea for blah, whatever. And the first question we ask is, well, is this just an idea, or have you actually got a partial implementation of it? Is there an open source project that has been kind of working on this for some time? Because typically that's the best way to do it. Standards organizations are not a good place to innovate. That's not what they're about. They're about standardizing something that typically has been shown in the real world to be important and needed. And typically there will be one or more open source projects, maybe they are separate or maybe one is an iteration of another, that have been exploring these ideas, and we have people actually using them in the real world, and gradually people coalesce around the idea and say, yeah, this is important. It's important that we have these technologies, and we're now at the point where it would make sense for us to do things in the same way, because we don't then kind of waste our energy having slightly different variations of the same idea. So yeah, you're right. Typically, and usually what we say to people is, if they come to us what we consider prematurely, we say, go away, create an open source project, run with it, get some real world feedback, have some real world implementations, let people see how your ideas are going to work out in practice, and then come back. That's the best way to do it. So it's not that open source and standardization are in conflict with each other. They're just different and complementary, and they work, in fact, very well together. Okay. Losing my voice. I think we're out of time. Thank you for coming. I will be around for the rest of the day. So if you have any further questions, just grab me. Thank you.